Hey, what's up? It's your boy, the Backflow Bro. We're out here, Queens, New York. Wanted to show you a couple things. We're at the Master Plumbers Council. They're a good little company. They mostly deal with master plumbers in the city of New York. I think you actually have to be a master plumber to be a member. But they do a ton of different classes. They host our classes. As you can see, they got like water heaters, different gas lines, gas regulators. They do a lot of gas stuff. They do also like plumbing training and stuff like that. But today we're going to go over our new PowerPoints. They're not actually part of the curriculum yet, but we're putting them together now. Probably submit them in like 2025. It's currently December 2024. But a lot of people were commenting. We actually just reached 1,000 subscribers. Actually, the cameraman is our 1,000th subscriber. If you want to say hello. No, he doesn't want to say hello. All right, you'll probably see him in some other videos. He's got a lot of different training on like how to start a backflow business, stuff like that. But anyway, they got a pretty nice classroom. And then we're just going to go over these PowerPoints. A lot of people were saying, like, oh, you got a lot of good stuff, but like it's all practical. It's all like, are you taking a test? But we want to just get some informational stuff as well. There should be a link in the description with the website, and then also some like timestamps on if you wanted to start a little later in or review different things. But anyway, the first one we're going to go over is check valves and how to test them. Like, what is a check valve, how they work, and also the different types of ways to test them. Check valves were patented in 1907 in their first version. There's a lot of different types. Over the years, they've come up with different systems that work. You have swing, wafer, lift, ball, inline, other things. The general premise of a check valve is that they only allow flow in one direction. So essentially, they'll flow through the check valve, but they won't flow back from like in the other direction. Generally, they're in plumbing, they're usually either swing or spring checks and piping. The ball checks are more for like plumbing fixtures, a lot of different ones. For backflow prevention specifically, they're pretty much always like the spring inline style. And they don't really last forever. They require service over time. There's different components, they fall apart, the springs break, the discs get out of alignment, or they get corroded, or you have like calcification that causes problems. So the general premise is they're good, they should only allow flow in one direction, but they may malfunction, so they typically have to either be serviced or tested over time. The first one from 1907, I guess the guy Frank P. Cotter is forever immemorialized in backflow texts and things like that. It just kind of looks like a lift check. It has an integral 90 in the patent. It's gravity based, so there's no spring. It's like the water pushes the check up and then gravity brings it back down. The USC 10th edition shows that there was an RP in circa 1903, but I don't think that's correct. So I don't know who wrote the USC book. We might have to send in something to them. There was also a valve called the Tesla valve. It's not really like a check valve in its modern form, but the idea is you just put a bunch of piping in there, and the water like goes in the wrong direction, and then stops the water from flowing. It's not super practical though, because if there is no flow, like say like one side had glycol, it would actually just dilute through the check valve, or if you have like very low flow. So it's not super practical. I don't think anyone really did anything with it. I think Tesla went later and like invented a bunch of electricity stuff, but it was pretty cool. But it's also a possible way you could stop flow in a piping system without a check valve. But because the fluid's dilute, you can't really use it because like the glycol would just fly back through the check valve. Modern types, you have the swing and lift and ball check. Ball checks are mostly in like plumbing fixtures. The swing and the lift checks are pretty common in plumbing systems. The lift is specifically more common in like hydronic systems or process piping. The inline check, spring loaded usually, or some type of spring involved, is generally what you're going to see in backflow preventers. You have lift checks. Again, they're more common in processing piping. Flow lifts the check, and then backwards flow doesn't, like the check drops. Generally requires gravity, so you have to have it in the right orientation. With flow, the pressure drop is a lot higher than for like a spring check, because if you look at it, you kind of need to have like a 90 or I guess like a 90 up and 90 back down. So you end up with a little more pressure drop. Swing checks are really common in plumbing systems. They're not super common in backflows because we'll go over it in a little bit, but you have to put a spring in there somewhere or some kind of internal loading for it to be valid. So you don't really see a whole lot of swing checks. You also see them in drainage piping. I think like there's backwater valves and things like that. They're also called tilting disc. I think the USC book calls them tilting disc style check valves. But most people would call them a spring check. Or a swing check. Swing check valves, say you got 60 and then, you know, a half PSI drop. Somebody opens up a faucet. It introduces flow. The swing check opens. You know, if you stop flow or you have back pressure, you end up where it closes. Again, some manufacturers, I know Ames uses them a little more than other people, but they use a swing check, but it includes what they call a hinged spring to create the differential pressure required. There's also a couple of like just really different ones. These are from Ames 4000 series. They have what they call like a cam check, where essentially like you have this thing here, I guess they call it a cam. Then the check valve opens, it opens it up, and then if it closes, it pushes it back up. And then this is just a standard spring check. So. Also, if you ever mess with the Derringer series, I'm a big fan of Derringers. You see them a lot in LA, but I don't really see them everywhere else. But you do see, like, because, you know, LA, they're all sticking out of the ground, so you see them more. But essentially, it's got a, like, I guess an oblique disc, and then they kind of, these are really good for differential pressure drop during like a fire or something like that. Essentially, the check will actually get out of the way. So if you have extreme flow going through, the check will actually just kind of get out of the way of the flow, and it allows the water to flow more easily and with a less pressure drop. Also, they have the integral butterfly valves that are indicating. They're very good for fire systems as far as like cost effective and servicing them. So I'm a big fan of the Derringer ones, but they're kind of a unique style of check valve. So that's the general premise is in backflow preventers. They have to be, I believe it's the way it's worded is internally loaded. So they have to have a loading, and it all has to be internal, but it doesn't necessarily have to be like a standard spring and disc, which is more what you'd see in just standard backflow preventers. You also just have check valves sometimes instead of backflow preventers. This is what they call a detector check. I was working with this, doing a private class in Maryland, and evidently they just put these on the fire systems instead of a double check. I'm not sure if that meets the codes. I'm not sure. I think it definitely doesn't meet the codes in most areas. But essentially it's just a check, and then it has like a little meter on it, and another check. So you have like a small check here, and a big check here, and then a meter. So instead of having like a double check detector check, they'll put like just a detector check, they call it. And then I guess you should be testing them, but I don't see any test boards. So I don't know if they're testing them as often because they can't test them. Inline checks, that's going to be, you see them a lot in plumbing systems anyway, but you see them a lot more in backflows. It's definitely like smaller diameter ones are pretty much always going to have these inline check valves. You can either have a spring behind the disc or attached to the front of it. And these will form the basis of the examples. We have like a lot of diagrams and stuff. This is basically the diagrams are going to be based on this. So you have a spring check, you have a spring. There's a few different components. You have a spring, disc, seat, and then just the housing. So say you have 60 and 59, you have a 1 PSI pressure drop. Somebody opens a faucet. The flow goes through it. Now all of a sudden the pressure drops a little higher. You notice now it's like 4. If you have flow through a check valve, the differential pressure across the check valve will increase. Then if you have back pressure, it just pushes the disc a little harder into the seat and it should seal. So whatever's on the more than 60 side won't get into the 60 side. This is kind of where they have springs, but they're attached to another way. A lot of times it's just the disc has a spring pushing it in the disc directly. This has more of a secondary housing and an extra spring. But the same idea applies. Water flow is introduced into the system. The check valve opens. If you have back pressure, the check valve closes. Or back siphonage. So either the supply pressure goes down or the downstream pressure goes up. Checks are designed to have what they call a drip tight seal. So essentially, if it closes, it shouldn't be leaking through. On backflows, they usually have a minimum differential pressure. You might only test the check under back pressure conditions, but either way, they should be loaded to have a 1 PSI minimum. The RP check valve 1 is actually higher. It's a minimum 5. The only reason it's higher is to facilitate the operation of the relief valve. The differential pressure is a drip tight seal, otherwise pressure will leak by. So you can't have it where it just closes. It has to close in a way that no pressure or any fluids or anything get through in the backward direction. So static condition, if you have a disc or a seat malfunction or the spring breaks or whatever, basically just leaks by. So it might be closed, it's going to stop almost all the water, but then essentially they're both equal on both sides. So if you had a back siphonage or a back pressure condition, it would definitely leak by. It's not always necessarily having backflow leaking through it if it's leaking. But if the disc or seat does not have a drip tight seal in either of the examples where the disc at the top is broken or the seat at the bottom is broken, it'd be a malfunctioning check valve and it would need to be repaired. You notice it when you're testing it, it fails the test, and then you fix it, and then it should be functioning properly. Or if you have debris. Also, a lot of times, we teach this in the backflow classes, a lot of times it's not that the check valve itself is broken, it's not that you need to replace a piece of it, it's just the disc is just stuck open due to debris. So a lot of times it'll fail the test, you open it up, you don't need to actually replace anything, you just kind of clean it out and put it back. You would think like, oh, so why don't I just check it to make sure I need to replace it before I get a repair kit? And the trouble with that is a lot of times when you open it up, everything breaks. So you take the top off and then the O-rings or the gaskets kind of rip in half and all that. So we recommend if you're gonna do that, even if it is a debris collection issue and all you do is wash it out, that you have the extra parts around even if you don't use them. Again, all backflow prevention assemblies all have at least one check valve. RP and double check have 2, but the other ones have 1. Check valves don't always work, sometimes they leak. So you have to test them periodically. There's 5 main ways to do a check valve test. I compiled most of this information from just doing the classes in different areas. Some of the standards, like the ASSE standard, doesn't refer to a couple of them. But they're all kind of in use in some part of the country, so they should be valid for whatever testing procedure you're doing on the check valve. And a leaky check valve, if you did any of these 5 tests, should fail. So it's not like if you do a reverse flow back pressure test, the check valve would fail in that test or in a static differential test. Either one would do it. They all have generally strengths and weaknesses, which we're going to go over in this PowerPoint. Static differential test. You attach 2 hoses, so one before the check valve, one after it. You bleed them. Most of the gauges are descending scale, so you usually have some kind of system where you reset the gauge, or you open the low and close the low, or you just close the low second to get it on the descending scale. You got to have full pressure on both sides. And all it shows is the difference between the 2 zones. It doesn't necessarily say the check valve is not broken, it just gives you the difference in pressures in the 2 zones. So there's a big weakness on it where you have to do a no-flow test. So you have to confirm that it's in a no-flow condition. So the USC procedures, what they do is they loop the bypass around to test cock 4, but there's a lot of different ways. You could actually just do a no-flow test, and then if it passes that test, then do the check valve tests. Otherwise, you could be testing an open check valve. So an open check valve, even if the check valve is leaking, the disc or seat malfunction is present. If you have flow through it, a lot of times you'll still get a passing reading. So that's the big weakness. So here we have this is our Kruger Instruments test kit. Check out the description if you're looking for a test kit. We have a lot of different things going on with that. But this is just a standard 2-valve test. Some people might be using more valves, like a 3 or a 5-valve kit. All of our stuff is generally based off the 2-valve kits. So you just attach 2 hoses, high and low. Bleed everything out. Close high. When you close high, the pressure goes up even further on your test kit. Then you close low and it'll drop down to wherever the drip tight seal is. Again, the big weakness here is that you have to confirm there's no flow through the check. That means you have other different tests. I've had a couple, I know we got one instructor, actually the instructor who's teaching this class, Tim, you might meet him, but he seems to be confused about that sometimes, but a lot of people just do like high to 2, low to 3, get your reading, then you just move over high to 3, low to 4, get your reading for check valve 2. But you do have to confirm there's no flow. They added that in like the 2000s, so some of the older school guys who took the original class in like the 90s and stuff, they just think it's like a waste of time. Like, I'm not gonna bother doing extra steps that I don't have to. But you do, the current standards do require a no flow through the check. So yeah, again, the big weakness, check valve could be open, so there's always some no flow condition tests. The big strength though, which is a bigger strength, we used to do almost all one hose stuff, but you only have to shut one of the shutoffs, and so you only shut the second shutoff if you're doing a static differential test, because you have line pressure coming through the number 1 shutoff, you don't even close it. And if you shut the first shutoff, like say you're doing one of the other types of tests, a lot of times when you reopen it, so say you have like full line pressure behind a shutoff and nothing, like 0 after, when you open it again, you actually like kind of mess up the valves. We're actually making fun earlier during the class where essentially for the USC test procedures, you have to do the 1 hose on double checks, and a lot of times the double checks are bigger, they usually have gate valves. And USC, and we'll go over in other PowerPoints or if you watch our other videos, essentially they have all these extra procedures in case the shutoffs are leaking, and we're kind of like, well, no wonder the shutoffs are leaking. Like, you're 1-hosing all the double checks. Like, if you're 1-hosing these 8-inch gate valves, you're gonna probably have some of them that start leaking, because every time you open it, it kind of like messes up the valve, or it can. Also, one of the other strengths is the gauge and the water level on the test cock are not important. The 1-hose tests, you have to make sure your gauge is exactly level with whatever you're testing or whatever the high end of the water is on the low side. Whereas this one, I mean, you could have it just in any, and that can come into helping you depending on where the check valve is located. Like if it's underground, you might not be able to get down there. Like if you're doing a double check that's like in a vault, you might not be able to get your gauge down there as easily. And if you're ever doing these tests, make sure you drain your test kit. A lot of people don't, and what happens is you might have like calcification in the kit. There's a lot of different problems that can come in from not draining it properly. Also, they freeze more readily. So if you're gonna fill both sides of a test kit up like that with water, you might just wanna make sure you drain them. The next one we're going to talk about is the directional flow test. Some of our materials over the years, they call it the direction of flow test. And the only thing I can come up with on how they came up with direction of flow is I think the Florida people, like University of Florida who made the textbook, just like misheard them when they were talking or something. Because like direction of flow doesn't really even make any sense. But if you look at the ASSE standards and a lot of that stuff, it's directional flow. And essentially you just have a single hose to the high side of the gauge before the check valve, pressurize it. If you're doing a directional flow test, you want to use a short clear hose. This can help you determine the level, and you're just supposed to per the standards. Some people don't, they just make it level with the test cock. I would say you always want to kind of have a short clear hose. You could either have one with a 90, you could have one without the 90, you could have one swiveled, however you want to do it. You also have to confirm there's no flow through the check, but that's actually just through the diagnostics. You verify that there's no flow because water's not running out of the short clear hose. So if you open up test cock 3, you're testing check 1, water keeps running. It's not necessarily just that you see that a shutoff is leaking, but also you're testing the check valve when it's open. So again, you cannot test check valves while they're open. So if you do a one hose test and water keeps running out of the test cock, you have to do some kind of way to bypass it. USC test procedures say you have like a little bleed off valve arrangement. You can also just use the high bleed on the gauge. If you look at the ASSE book, the IATMO book, they break it down where you can actually just bypass the flow using the high side bleed. So directional flow test, put one hose on the inlet side, you have your short clear hose on the other side, open up your high bleed, open up the test cock, close your high bleed, and then you just open up the test cock, or you close both shutoff valves, obviously otherwise water will go everywhere. Open the downstream test cock. Once the flow stops, so if water keeps running out, you got to do something. You got to either use your high bleed or one of the bleed off valve arrangements. Once everything stops, you have a reading on your gauge. That's the check valve. So essentially, if the check valve was broken, it would run through and come out, and then it'd go to 0. So if it's holding a number, that means this zone holds a number, this side has 0. The spring is pushing the disc into the seat, and if everything's functioning properly, that means that the check valve is functioning properly. Big weakness though, you have to shut both shutoff valves. And also kind of like allows air into the system sometimes. So if you're shutting both of the shutoff valves and it's a 10-inch backflow and it's a 10-inch gate valve that looks like it was built in the 90s, it's probably, just first off, the shutoff valve probably leaks. So you probably have like some extra steps you got to do. But also when you reopen it, you can damage it. So you always want to, there's a couple extra steps you can do to like recharge it before you open it. There's a lot of different ways to get around that to make sure you don't damage the valves. Also, small weakness, you have to make sure the gauge is at the proper elevation. So if you don't, essentially the head pressure can affect your reading. So say your gauge is 2 feet higher than the top of your clear hose, 0.433 times 2 feet. So you'd probably be reading, I guess, 0.86 PSI lower than you should. Also a big strength though, you can test the valve even with leaking shutoff valves. So if you're doing a differential pressure test and you have a leaky shutoff valve, like you do a no flow confirmation and it fails the no flow, like you're kind of screwed. Whereas with these, even if the shutoffs are leaking, you can still get a proper reading. Also, it's just like fewer steps, like it's a little simpler of a test. Next, we're going to go over the head flow test. This is not necessarily a legit test in most areas, but if you're just testing a check valve, it would definitely work. But if you're testing a backflow preventer, they usually want the number. But it's very similar to a directional flow test. But instead of the gauge reading, you just have a tight or not tight test utilizing head pressure. So you also just need a lot less equipment. In LA County specifically, like Los Angeles, they actually kind of like want you to do that test because I guess it's simpler for everyone. The idea is you have a sight tube to the test cock before the check valve, and then you have the short clear hose after, and then you measure from the top of the short clear hose up to the top of your sight tube, or some point, so maybe like up towards the top is 27 3/4. That's fine too, but it has to be at least 27 3/4 inches higher. And then, like if you know backflow and you do plumbing, you know that 27 3/4 inches of water column is exactly equal to 1 psi. Yeah, you just fill the sight tube with water, fill the short clear tube with water, close your shutoffs. Again, you do have to close both shutoffs, so the same weakness applies where you might like be messing up the shutoffs. Open test cock before the check valve. That kind of like bleeds off all. So say it's running at 60, you open the test cock before the check valve, it'll set it just to whatever head you have on that tube. Then you open the test cock after the check valve, all the water bleeds out. So the idea is the head pressure from this water, if the check valve was leaking, it would go down and equalize. So if it's holding it up at 27 3/4, you know the check valve is holding at least 1. The big weakness on the head flow test is that you don't get a number. You just say like the check valve is tight, it held at least 1, but you don't know if it was 2, you don't know if it was exactly 1, or if it was like 100 or anything. You just know that it held that 1, and that's good enough for some people. And then a lot of test reports that you fill out, they'll ask you like for what's your gauge model number, what test kit did you use, when was it calibrated, and then you just kind of like, I guess, say like, oh, I don't have a gauge, I used a head test, I guess, is what you would do. It's also a static back pressure testing. So there's 2 ways to do it, back pressure as well. So you might not even get the number, you might not even say like, okay, it's holding this much in the direction of it's supposed to, like the directional flow. It uses differential pressure on a previous check valve, generally check valve 1, because there's usually just 2 check valves and you're doing it on check valve 2. Use the differential pressure on check 1 to determine the tightness of check 2. And you position the gauge and hoses so you confirm it also, like the static back pressure test is nice because if you need a no flow condition test, you kind of have it all set up to do a no flow condition test like exactly after you do the back pressure test. Also, the position allows the tester to determine, so yeah, similar to that. If you close test cot 2 after you do this test, you can test the shut off 2 for tightness, if that's one of the required tests that you need for your jurisdiction. So essentially, we have the 2 hose model here. So you have high to 2, low to 3, and then you take the bypass hose and you run it over to 4. Open test cock 4. Open and close the low bleed. So you open the low bleed, it resets the gauge. And then you just open high bleed. So once you're finished with the relief valve test on RP, or if you're doing a double check, you just kind of do this right after you do check valve 1's test. So you open high, you're going to get a little bit of discompression, usually. It might drop from like 8 to 7 or 8 to 7.8 or something like that. So then you have to reset your gauge again to get check 1. So when you open high bleed, if check 2 leaks when you open, so you open high bleed, if check 2 leaks, it's going to leak through the check valve, and this zone will increase, and then your number will go down. So you see this more prevalently on the USC test procedures for the RP, but there's also a double check procedure that does these tests on check 2. It's a kind of common test. You see it a little more with the 3 valve kits. But again, we have the 2 valve kit. It's actually a lot more efficient, I think, and there's a lot fewer steps. You save a lot of time using the 2 valves. You can then reset your gauge and get a proper check valve 1 reading. So again, like we were saying, if this is a differential pressure test on check 1, because you have this looped here, if you had a flow condition, it actually bypasses the flow through the test kit. So now you've confirmed check 1's in a no flow condition without even testing shut off 2. Like the check valve 1's definitely in a no flow condition, because when you open that high, if check 2's leaking, it goes through. But then if the shut off is leaking on the other side, the water runs through the gauge. So it helps a little bit with that. If you're testing double checks now and you're not doing anything like this and you're just doing 2 hoses, you might want to like pick up the textbooks and reread chapter 9 or whatever chapter you're looking at, because you're not supposed to do that, and it's definitely not like as legit as doing it this way. Some people argue that the fire systems the double checks are on should never have any flow, so why would I bother confirming there's no flow? Good input question, but like, did you test the fire system recently? Like maybe it's leaking. Or maybe somebody's stealing water on the 10th floor and nobody knew about it until today. There's also a reverse flow back pressure test. I don't think that many people use it. It would be effective I'm not sure if that many water purveyors want you to do it. I really just saw this, that there's some school in Long Island that teaches it this way. But other than that, I've never heard of it. But it should be a good test. I like how it works. One caveat though, you can't do it on check 1 of the RPs because like it would just dump all the water out. But it can be worked on the, it would work on the double check. Like yeah, so if you had like a PVB, I wouldn't do it. You know, like a lot of them I wouldn't do it. It's really just on the double check if you wanted to do it that way. But it's pretty cool, so we included it in the PowerPoint. Hook the high side to the downstream side of the check valve. Pressurize. Close both of your shutoffs. And then you just open your high bleed and bleed the pressure down to some number that's easily referenceable. Most people do 5, but if you want to do 10 or you want to do 3, whatever you want to do, generally people do 5. And then you just open the test cock before the check valve. So the idea is if you had 5 here and the check valve leaks, when you open up this test cock, the 5 would bleed down and it would bleed backwards. So it's a pretty cool little test. I think in Iowa they do them. I remember like some part of Iowa people were talking about it. And then if you check the test reports on Iowa, they want back pressure tests on both check valves. Like it'll say like, did it pass differential pressure or did it test back pressure? But on both of them, not just check valve 2. So I think they were being legit about it. It is a 1-hose test, so it kind of has the same weaknesses where you have to shut both the shutoffs. So make sure you do that carefully if you have a big gate valve. Again, these are the 5 types: static differential, directional flow, head flow, static back pressure, and reverse flow back pressure. So anyway, thanks for joining us. Definitely check out our other stuff on the channel. We got a few different more PowerPoints like this at different classes we're gonna do. Definitely check out the channel. Please definitely like, subscribe, whatever you want to do. We're trying to get up, we just hit 1,000, but to monetize, I still need like more people watching the videos or something. I think I need like 4,000 watch hours or something like that. But definitely follow us. If you're interested in doing backflow testing, it can be a very lucrative thing to get into. Check out our website, it's krugerstraining.academy. We got classes in a bunch of different states. Or if you need a backflow test kit, check us out, Kruger Instruments. But again, thank you for joining us.